Hello, it's Dumplet here. Here's an item on algebra. X and y are non-zero solutions to x squared plus xy plus y squared equals 0. Find the value of this expression here. Credits to the Berkeley Mini-Math Tournament back in 2015 for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now let's first take a look at the given, because we have x squared plus xy plus y squared is equal to 0. And this is kind of familiar. It's the left-hand side is one of the factors. If you factor x cubed minus y cubed, the difference of cubes, because, well, in this case, if I multiply both sides by x minus y, we should be able to see that, well, this is just the factored form of x cubed minus y cubed here on the left-hand side. And the right-hand side just becomes 0. Now, this is a particularly interesting result because, well, first of all, we can say that x is not equal to y. Because, for example, if x was equal to y, right, if x was equal to y, then this part, if x was equal to y, it's just x squared plus x squared plus x squared, so that becomes 3x squared equals 0. And that's going to give us x equals 0. But we have x and y to be non-zero solutions, so we can say that x is not equal to y. Well, pretty weird to have x cubed minus y cubed equals 0 here, but probably we have some complex solutions here that allows x cubed over here to equal y cubed. Again, I'm not saying x equals y, but instead we have x cubed being equal to y cubed. Now we can use this result pretty interestingly here because, well, take a look at this expression. This becomes x raised to 1008, and specifically we focus on the y raised to 1008. And the y raised to 2016 over here. Because, well, x cubed is equal to y cubed. So, and look at this, 1008 and 2016, they're both multiples of 3. So I can replace those two green terms, y raised to 1008 and y raised to 2016, as x raised to 1008 and x raised to 2016. I'm not saying that x equals y, but I'm using the fact that x cubed is equal to y cubed. And it so happened that 1008 and 2016, they're both multiples of 3, so I can use this fact. So the numerator here actually just becomes x raised to 2016 plus, well, since this term, y raised to 1008, becomes x raised to 1008, so it also becomes x raised to 2016. And then the last term becomes x raised to 2016 as well. Then we're going to divide everything by 2016 power of x plus y. So the numerator is just 3 times x raised to 2016, as we have here. Now, let's try to deal with the bottom one because, well, yes, I didn't replace y with x because I'm not saying that y is equal to x. So maybe we could do something different here. Now, let's try to use this one because I realized that if I expand this, if I take the square of x plus y and then we're going to raise the denominator, we're going to raise this to the 1008 power. That's going to be the same as taking x plus y raised to 2016. Now with this, however, we can expand the x plus the square of x plus y inside the parentheses like this. So we have x squared plus 2xy plus y squared, and then we're raising it to the 1008th power. But since we have x squared plus xy plus y squared to be 0, this thing in the middle is just simply xy. So essentially we are doing xy raised to 1008. So we have here xy raised to 1008. Now this is something similar to this middle term, because what we're going to do here is we're going to do the distribution of exponents. We're going to have x raised to 1008, and then this y raised to 1008 over here, because we had the relationship x cubed is equal to y cubed, and 1008 is a multiple of 3, so we should just have, instead of y raised to 1008, we can write this as x raised to 1008 as well. And that's going to give us x raised to 2016. So apparently, the denominator is just x raised to 2016. So writing it down, so we have 3x raised to 2016 in the numerator divided by, we have x raised to 2016 in the denominator. We can cancel the x raised to 2016s, and that's going to give us the final answer of 3. So we didn't have to get x and y, but just through algebraic manipulation, based from what we know about some factoring and some properties of exponents, we were able to reach the final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!